Hello everyone, this is Professor Vishal Gupta at the USC Marshall School of Business. This video is for BUAD425, Data Analysis for Decision Making. In this video, I'm going to show you how to use Excel's data table feature in order to search for the best value of a threshold in a binary classifier. Let's get started. I'm going to be using our now familiar loans dataset. If you don't have a copy of this spreadsheet, you can download one off Blackboard. And in particular, I'm going to be using the version of the spreadsheet where I computed these confusion matrices to the right using Excel's COUNTIF function. And that's because the method I'm going to show you right now to optimize the threshold won't work properly with pivot tables. If you want to see a video on how to create this spreadsheet with COUNTIFs, please check the other video uploaded to Blackboard. Okay, now as we discussed in class, the cost that we incur as a bank for offering a loan to someone who ultimately defaults is much larger than the cost we incur we do not offer a loan to the same person who would have ultimately paid. So there are very asymmetric costs in this confusion matrix here. So here on the bottom, I've computed an estimate of our returns for this linear classifier as we did in class. And in particular, I'm assuming a few things. I'm assuming first that every loan that we offer someone is for $1 only. Secondly, when we offer a loan, if someone pays it back, we earn 3% interest. And third, if they default, we lose the entire principal. And because of that, I can estimate the total expected return for this classifier as 0.03 times the number of people that we predict will pay and actually pay, minus 1 times the number of people that we predict will pay and actually default. So for the linear classifier with a threshold of minus 11, our expected return at the moment is something like minus $417. All right, now, as we discussed in class, we're going to want to change this threshold to see if we can do better than that. And one way to do so would be to just simply guess new values and look at what the expected return is. So for example, if I go to minus 12, I can see the expected return is now minus 2.8. Or if I go to minus, let's say, 12.5, I can see the expected return is 1.53. But if I hunt and peck in this way, it's sort of hard to know when I found the best value. So an alternate way to do this is to use Excel's data table feature. Excel's data table feature is pretty useful. It allows you to pick a specific input cell and a specific output cell on a spreadsheet and then perform what-if analysis. So it's going to automatically compute your spreadsheet for every value of the input cell and return the corresponding value of the output cell. So let's see how this is going to work, particularly here. So the first thing I'm going to do is I'm going to build a grid of possible values for the threshold. So I would like to know what the profits are if I move the threshold between minus 13, minus 12.9, maybe all the way down until, I don't know, minus 11.4. So these are all the different inputs that I would like to place into this threshold, and I would like to see what the corresponding profit or output is. So right here above the list, I'm going to show Excel which is my corresponding output cell, the profit I care about, which in this case will be here. Once I have my cells set up in this way, I can select the entire table and then go to, on Mac, Data Table, and on Windows, it's under What If Analysis, Data Table. And if I select this, I can see this pop-up window appear. Now I've placed my grid of input values in a column, so I'm going to leave the row input blank cell, but I'm going to go to column input cell, and I'm going to tell Excel where do these inputs belong. So in this case, I'm going to select that the inputs all correspond to this threshold. Once I have this set up like this, I can hit OK, and Excel will go off, and it will recompute this spreadsheet using each of these values in turn for the input cell, and returning to me each of the corresponding output values here. So I can check this. I can pick a value down here, say minus 11.8. If I put that in, I can see that the output should be minus 17.36, and if I check my table, indeed, Excel has computed that. Once I have this table of possible input thresholds and the corresponding profits, I can simply scan it to say, look, the maximum profit is around minus 12.1. Or I can choose to make a chart just by highlighting the values, inserting a chart, and inspecting visually that the maximum seems to occur at minus 12 points. If I really wanted to, I could change this grid of values to be more concentrated about minus 12.1 to see if I can learn a few more digits. Excel makes this really easy because I can just change the grid of input values over here and it will compute the new output values on the fly. So for example, I can write here minus 12.5, let's say, and you can see it's already recomputed these values. Here I'll write minus 12.45. I'll extend these down. And now I can see a slightly more fine-grained view of what the profits look like for values of the threshold. In most applications, you don't need that much accuracy around the optimal threshold. A few digits will do. And in my case, I'm pretty satisfied with minus 12.2. So that's all there is to finding the best threshold. But importantly, the difference in profit between a good threshold and a bad one can be massive. So notice that for our optimum threshold of minus 12.2, we're making a small profit at 3.29, but at our initial threshold of minus 11, we were making a huge loss of minus $400. So always, always, always tune your threshold for your specific application. If you'd like to practice, you may want to try and define the best threshold to maximize the accuracy of the classifier. Although this isn't particularly useful in this business application, it's useful to see how different it is from the best threshold for profit. So good luck, and let me know if you have any questions.